Example 6.7 or 7.7 for the given textbooks. For details, please see the description below. A heat pump is to be used to heat a house during the winter. The house is to be maintained at 27 Celsius at all times. The house is estimated to be losing heat at a rate of 135,000 kilojoules per hour when the outside temperature drops to -5 Celsius. The goal of the problem is to determine the minimum power required to drive this heat pump. The first step is to calculate the value of the coefficient of performance. This is going to be done for a reversible heat pump. Reversible heat pump. The reason we want to use a reversible is because that is the highest amount of coefficient of performance that we could have for this particular temperatures, and that will give us the least amount of power required to run this heat pump. So we do that simply by saying 1 divided by 1 minus the low temperature divided by the high temperature. Remember, coefficients of performance need to be done or calculated using absolute values. So 1 minus the low temperature, it's at -5 Celsius. So we add 273 to make it into Kelvin. And then we do the higher temperature is 21 Celsius plus 273. And we do this calculation and we found that the coefficient of performance is equal to 11.3. Before we calculate the amount of the power required, we need to convert the amount of heat that is being lost from kilojoules per hour into kilowatts. So we're going to do the conversion of Q.H, and that is equal to 135,000 kilojoules per hour, and we're going to convert that into kilowatts by simply saying that 1 hour has 3,600 seconds, and that is going to give us a value of 37.5 kilowatts. Now that we have this value, we're going to calculate the amount of the minimum power by simply using the relationship for the coefficient of performance using the heat rejected and the power going in. Simply, we're going to solve that equation for the amount of power required. That is equal to the amount rejected divided by the coefficient of performance for the heat pump. Therefore, we use the value that we just calculated, 37.5 kilowatts, and the value of the coefficient of performance calculated previously. And then we find that the minimum amount of power required is equal to 3.32 kilowatts.